Hello, hello. What's up, Marcel? Let's see. What did I just press now? Yeah, so guys, there's gonna be some noise in the background. I might keep my mic muted. Let me know. So every year around this time, it's like school start, and I live in a neighborhood where there are lots of students, and there's gonna be a lot of parties. If I sound tired, it's not because I was on a party. I was actually on a trip with my younger brother earlier today, which was fun. And then I took a power nap. So I woke up from the power nap, and I was considering, should I go have some takeout? But then I thought, I'm saving money. So I made, I was going to make oyakodon. Let's take a look at what that is. Yeah. So this is what I wanted to make, but my chicken is frozen, so you can see. So it's a Japanese recipe where you have some. In this case, they just have some vegetable thing on top, and then some chicken. Looks like chicken, and then some egg, and then rice beneath. It's delicious. I'm telling you, like making this, it's so easy to make and so tasty. If you haven't tried making oyakodon, I recommend it. So I was gonna make some oyakodon, but instead of using chicken, I decided to use mushrooms, and that was actually really good. So yeah, tasty. I wonder if there is a recipe for that. So I just mixed up like I didn't have an official recipe. It looked something like this without the chicken and the green stuff. So yeah, definitely fulfilling meal. And I made too much rice, so maybe I'll eat some more tonight or for breakfast. I still need to make the egg again, but have you tried this? It's so chill. And let me have some green tea. Yeah, so that's oyakodon. Very easy to make. You just cook some rice. Ideally, you should let the rice be in water for a few hours and then wash it, or maybe wash it before and then put it in water for a few hours to cook it. And you fry some. I don't remember the order, to be honest. I think you fry some vårløk, whatever this is called in English. This thing here, you fry this thing here, and then you put. You don't need to use oil. You can use soy sauce to fry it. A leek? What's up with the leek? Oh yeah, okay, that's the name of it. Okay. Or maybe I'm misunderstanding. She has a mascot? I didn't know that. Had no idea. Yeah, she actually does look like a leech, doesn't it? With her hair. Or it's just the mascot. What is this? Angry Miku. What's this website? Should probably be careful visiting websites like that. Cool, I had no idea. So yeah, we'll be continuing on this project. My voice might be failing a couple of times. And I prepared a talk. Have you guys heard about this YouTube channel called Google Tech Talks? I'm assuming it should be fine to... oh, they have a video on Advent of Code behind the scenes. Nice. We should check that out someday. But basically, I think their talks are in the public domain. I think. I don't know. Maybe we can check. Is there any... So we're gonna watch this talk while writing some code. GTAC, Google Testing Conference something. Let's look that up. Probably says it in the description. Google Test Automation Conference, right? So yeah, I unfortunately still produce crappy code, guys. It's not so reliable. I wish I made more stable software, so we're gonna continue writing tests and stuff like that. And actually, let me have a browser here on this side, so I make sure. So how is the noise? Can you actually hear it? I hear like really loud party noises in the background. I'm hearing people screaming here. The mic shouldn't pick that up, but yeah, my neighbors are. It sounds like somebody's doing karaoke, but they're just having a huge party. Yeah, so Google Test Automation Conference 2014. There's a playlist. We might check that out. But for now, we want to start with this one, this talk from 2014. Move fast and don't break things. So the reverse of Facebook. What the? Have you watched this? We should actually watch this talk sometime. I don't know where this post is. EcoCells, I have no idea. But I've seen this mentioned before as the motto of Facebook. Here it says. So that's not what we're doing. We want to move fast and don't break things. And this guy joined Google in 2003. He was lured by free food. Who wouldn't be lured by that? That's actually a really nice benefit. But in Norway, actually, they've really hit down hard on that. If a company gives you a lunch or any kind of food, really, they have to tax deduct it. At least if it's on a frequent basis, I think. So it's like it's considered a benefit. So you have to pay taxes. It's ridiculous. It's I want lunch at the office, but I feel like, come on, why are they pushing so hard for it? It feels like you're in a communist country where you have to tax absolutely everything. Anyways, he got an opportunity to play a role on how testing evolves at Google. Over the 10-year career at Google, he has worked in many product areas and currently leads test efforts for social product area at Google, which consists of projects like Google Plus. Is Google Plus still a thing? I wonder if it's still around, Google Plus. What happened to Google Plus? What happened? On April 2nd, 2019, we are shutting down the consumer personal version of Google Plus, a social network. Yeah, it's dead. Photos. Imagine developers who have integrated with Google Plus, right? It would kind of suck if your product is heavily dependent on Google Plus and then they shut it down. That sucks. It reminds me of the Microsoft Silverlight episode. Photos, Hangouts, Blogger, News, etc. Ankit is particularly interested in pushing the limits on the balance between velocity and quality. Let's just look at images for the word velocity. Okay, so velocity essentially in this sense means shipping faster, basically. What is velocity? The velocity of an object is defined as the displacement covered by it per unit time in a particular direction. The simple used to represent velocity is v small, blah, blah. Yeah, so that's the talk. Let's try it. Hopefully we're not going to get hit by copyright strikes on YouTube. We'll see. Maybe I should bring my headset. Where did I think I'm going to turn on my headset. It's kind of annoying with all of the party noise from the neighbors. And to be honest, guys, they're not really singing that great either. It's if they were singing well, I could have just listened to it. But as background stuff, it gets really annoying. So headset on, and let's play this talk. Let me know in the chat how the volume is. I'll try to increase it to max and then see. And actually, let's close other tabs. And yeah, let me have some more tea.
Thank you so much.
I think we want subtitles. Is that enabled?
Morning.
Good morning to you too.
Good morning.
Good morning!
Okay, good.
How's the sound?
Seems like everyone's had a late night. Good. Welcome. I'm getting old. I'm going to hold on to this. Mostly to stick to the script. I don't have this keynote or 3-hour one. What I was going to be talking about today is a topic which is very near and dear to my heart.
What happens if we go to full screen? Does that work here? Yeah, it does. Nice.
Is how do you move fast and don't break things? Because I think each one of these things are interesting to do in isolation, but to do them together poses some interesting challenges, opportunities, and we've had a fun ride for about the last half a decade where we have, I think, done this, and we think we have it down to the point where we would like to share this with all of you, so you guys can get a perspective of how we try to do this at Google. But more importantly, you can help us make this even better going ahead. Quick thing, GTAC. I mean, we have last time we did this was in New York. It was widely successful. The New York one was based on a theme. I don't know how many of you were there. And we somewhat felt constrained with the theme, so this year we decided to keep it open-ended. We roughly had about, this time we had about 1,500 speaker applications, which was roughly about 3x of last year, which to us gave us the signal that the community is still very much engaged with GTAC, which is a great thing. That really enables us to keep doing this. Out of the 1,500,
Let's
about
get this
200 were
started.
Googler applications, and about 1,300 were external. And of those, 250 of you are the unlucky ones or lucky ones. You'll find out in a couple of days who get to spend 2 great days in this room. And the speakers, we have about 15 speakers. What do I like about GTAC? The booze is great. We can't put it on the slide. Oops, this is recorded. But on a more serious note, I think what has amazed me about GTAC is to really get a chance to interact with most of you guys from the industry. And it's an interesting variance in how testing is approached differently in different industries and different segments of the tech industry. And I think we've valued at Google at sharing what we've done within Google, but I think we've gained more from learning from the experiences some of you guys have shared at GTAC. So again, thank you in advance to all of you who are going to be talking about, the other speakers are going to be talking about stuff. So why am I here? Yeah, I've become one of those guys who spends a decade at a company. But Google's a pretty good company to spend that decade at. I'm over the years, due to the kind of work I've done at Google, I'm super passionate about, again, the balance between velocity and quality, because it's almost like a two-edged sword, and you need to balance that. And yeah, I think I just want to be able to share with you guys what we have done. Quick history of my career at Google. I started about 10 years back leading testing efforts for Google Desktop. There used to be this thing, there was a time people used to build software for desktops. So did Google. And then I moved on to leading efforts for anything Google that you installed on any operating system, toolbar, desktop, Picasa, so on and so forth. After that, I moved on to Gmail, which was great. For the first month, I literally tried to figure out how to find a DOM on Gmail, but then I realized I couldn't. Then after about 3 years on Gmail, I lead testing efforts we bucket these projects under an umbrella called social at Google, but projects like Google+, News, Blogger, Hangouts, Voice, etc., things like that. So very quickly, some of the things my first automation project at Google, I called it MAD.
What does that mean? Object is of type unknown.
We had to create content, a lot of content which we could stress test the Google search appliance and Google Desktop with. And so it was fun UI automating Word, Excel, AIM. I don't know how many of you even remember what AIM is, but AIM. Back then, Google used to use a variant of Bugzilla as their internal bug database. It was running under someone's desk. That was Google 10 years back. It started getting really slow because turns out 1/5 of the bugs on the bug database were from my team. So she's like, yeah, you guys need to take care of this. And then it kept getting slower, and I essentially, one fine day, got sick and tired of it and just made it 10x faster. What did I do? I just moved it to a faster machine in a data center. But this one does what technology.
Horizontal scaling, yeah.
I worked on a 20% project called Survey Tool. The reason I talk about this is this was my first real-life example of how not to do things, in terms of how this grew organically, much to initial joy, later to dismay, gained traction. In that day and age, there was no app engine, no Google Forms, no Google Plus polls, what may. And so it grew through the point that at one point, Google HR wanted to use it as the tool for our annual survey. Within literally, I believe it was less than 3 minutes, the tool melted. After we sent out this email to Googlers, I spent the next 2 weeks pretty much like recovering data, and then I happily retired the tool after a month. So, but that was a good learning experience. And one of the reasons I am doing what I'm doing, and I like test engineering is when I was doing my bachelor's, I worked with a buddy, and we worked on a microprocessor control pick and place manipulator, which is a mouthful way to say a robot. But that really gave me a perspective that while software is great, hardware really, for those of you who work in hardware, I salute you guys. Hardware is a lot more difficult to mold.
I believe that.
I remember ending up spending 10x more time. So what is test engineering? We we tend to think we have a dual purpose at Google. We think we want to build the infrastructure and tooling that is going to enable us to test things at a scale that no one else tests things at. And the other focus we have is we want to test and automate projects, right from things like the autonomous cars to things like glass, to things like, one of my teams tests these. I like to use it, like how blue is your blue in terms of photo editing software, which is a very tricky problem to automate if you come to think of it. So, but that's kind of how we think test engineering at Google is all about. This is how Google looks from the outside. Everyone's like, yeah, this is the world of Gmail, Chrome, YouTube, free food, shuttles, massages, paddle boats. Wow, it's awesome. I'm sure it's probably a fun place to sit and code too, and it is, depending on what your definition of fun is, and what part of the code base you are in. But this is more like how it is, or surely does feel at least 3 of the 5 days of the week. I guess great things come with great pains. I don't know if that's a saying and I made it up.
This is one of the things that's annoying with TypeScript. Like, I just have no idea how to solve this. It's gonna complain. We need to resolve this. Because here, I'm trying to change the type. Let's start over. So here it's, here we're setting the context, zip, so it should know it. But here it's still complaining where the context is of any. So we can probably force cast this and get it working, but it just feels wrong.
Right, but the rich products, I mean, we have great products which have rich integrations, but that leads to pretty interesting and complex stacks. We have legacy code bases, and the moment this resonated with me was probably a few years back when I was on Gmail. I wanted to add a feature in Gmail to integrate this thing we have called Google Feedback into Gmail. You probably, if you go to Gmail right now and say send feedback, and I was like, yeah, that should be a 2-day thing. I'm just adding a module. Every feature in Gmail was a module, and I'll have it. Turns out I added a module, but turns out, of course, there was a lot of refactoring which had to be done in another module. And then when I did that, there was race conditions between the module. And then turns out you have to handle the JavaScript, you have to lazily load it. So you also have to ensure that the JavaScript is not too much because you're causing every user to download this every day. And then you have to write a unit test, and then you have to write a UI automated test, and then you have to write an integration test. By the time I was done with all of this, it was 2 months. I was like, wow, that is shockingly sad. I did get that done, but I very rightly went back to all the guidelines and principles we had in terms of how to write a feature and what are the things you need to do, and revised that and made it like it was good to get that perspective. So that's kind of really, I think, a lot of what Google is. Via this slide, I wanted to take an opportunity to highlight, I mean, the code throughput at Google continues to grow linearly. Ever since, I think, Ari spoke about this in the last keynote, and I've been kind of tracking this metric. I like graphs, so tracking this metric, and I've been hoping.
It was actually written in the docs. I should have just read it properly.
Slow down as we add more people. Bigger companies things get harder to do. That's kind of what you hear. Except at Google, that doesn't seem to be the case. Another interesting tidbit I found, I think this is probably true for every tech company in the, I guess, but it's interesting to see the peaks. Like, there's a peak right before the holidays, after the holidays, and right before Google I/O. So kind of shows through, yeah, it's working as intended. That's what engineers do. Yeah, I got my slides together like 5 a.m. yesterday, right? So that's what happens. And the trend down correlates too. I mean, it's the holidays, but I have no clue who's still checking in those 10,000 CS. Who are those people and why? Yeah, so that's something we got to fix. That's way too much code going in when you shouldn't be getting code in. Another, because we've had this, Larry strongly believes in velocity, and we've had a very sustained push over the years on velocity, and we've made a bunch of things around that. That in turn has made us really efficient in how we do our releases. And we've had a bunch of other new product offerings, Google Fiber, things like balloons and whatnot. We almost, but it's still shocking to see we are doing almost twice as many releases. I think this is another testament to, I want to give a shout out to the release engineers we have at Google. I think they've done an incredible job in automating a large part of our release tooling and workflow to make it really easy for the teams, individual teams, to really sustain themselves in a lot of the tasks needed for release. Of course, our SREs rock. While we continue to push out all these releases, they ensure Google and all of our infrastructures almost stay up always and have a very high availability. Google actually publishes this number on our apps dashboard for our apps, and it's kind of insane, the availability we have. So I like memes. I had a lot more memes. Legal made me take them out, but some stayed. As I've been talking to teams within Google and to folks in the industry, I think a theme emerged to me. A theme about, when I started hearing, or I hear Googlers who leave Google and join startups, and they're like, wait, we kind of feel stuck. We are a startup. We should be able to release quickly, right? And a lot of people end up having long release cycles. And the definition of long can vary from a few weeks to a few months. But as a result of that, everyone then wants to get stuff in because they're like, wait, the next release is ways out, so let's get this out with this release. But that, in turn, essentially, I call it a lack of discipline. It leads to further problems. It leads to further regressions because you're trying to put in stuff which isn't totally baked. It leads to delays. And that, in turn, is once you are in this, it's kind of a hole you keep digging yourself into. Once you're in there, and if you encounter problems, you're so deep in the hole that there's no way to isolate it. The only way to get out of that is fix that problem and fix it and work around it. The context, this slide is important because this slide is maybe the reason why you guys are going to be sitting here and listening to me for an hour. About a bunch of years back on Gmail, we suddenly realized that we need to iterate faster. While what we thought we had a pretty good release cycle, which was weekly, we realized that even though we have weekly cycles, by the time our code makes it to prod, from the time it's checked in, it's 3 weeks. So while we were cutting weekly, that code took 3 weeks to get to prod. And that had a bunch of problems. That model had a bunch of problems because it hindered our ability to react quickly when we needed to. It also meant that there were 3 parallel tracks, which means if you had found issues, if you find issues somewhere, you have to ensure you down integrate them on all the branches. There are conflicts, and it's just one specific example I can remember is we pushed a certain Gmail release to prod, and there was the initial page load, I guess the inbox, when you load the page, it slowed down by 20% on IE. We had a laser focus on latency, and we still do at Google, and so that wasn't acceptable to us. We did have what we thought was a state-of-the-art regression system, latency regression system, which could actually help us detect regressions of even 25 milliseconds. But that thing didn't show a blip, but in production we saw a big spike. And then that led to an interesting wild goose chase, which eventually after 2 months because then we were iterating on production, it further accentuated the 3-week delta problem we had. And not to mention we were literally pushing code to our prod users and continuously updating it. After what felt like a 2-month goose chase, we narrowed it down to a change list, which introduced a pseudo hover rule, which in IE causes the entire style sheet all the rules to be reevaluated. every time you move the cursor from, just move the cursor from one element to another. And the reason our system didn't catch it is we didn't have hover-based automated tests back then, because they can be tricky to automate. We did get it back in there. But that's kind of what really was the aha moment for us, and we said, this isn't great. We need to iterate faster. We need to ship daily. And that's how we set about this mission. Okay. We'll call this a bio break for the deck, I guess. Oh. I think this is the next, yeah. Okay. Moving fast is good, right? Everyone likes to move fast. But I wanted to add a bit more color to that. Innovation is no longer just the sexy thing to do. I think you need to do it to survive. We all know what happens to companies who don't innovate, especially in the tech industry. It also
I think the voice
really is a great way
lowered,
to
so
retain and hire talent, because people like to work for companies that are innovative and that move fast. And I think moving fast really enables you to do that. The ability to react quickly to critical bugs is huge, and I think moving fast gets you there. This is a chicken and egg problem, in my opinion, where you can't move fast. You can't react quickly till you move fast, but you can't move fast till you don't know if you can react quickly. And at some point, you just have to take a leap of faith and hope for these two to come together, and they do. We've tried this umpteen times, and it's come through in some way or the shape of the form. In some cases painfully, in some cases less painfully. Another side effect of moving fast is productivity is automation is a key ingredient to making this happen. And having if you want to move fast, you have the automation in place, which means if you're making changes in your workspace, if you actually write code that doesn't compile, you're immediately going to find out about it. If you're writing a code where you break a test,
we need a DB query to look up stuff. So
and I talk a bit more about how we do that. Or if you try to check in a change list without tests in it, we have tools at Google which actually will yell at you, though our human reviewers do a pretty good job of doing that too. And now I think this came about in the last couple of years. We have tools at Google which show incremental code coverage for every change list, which I think is extremely useful. Lastly, I think why moving fast really helps is it helps get the focus on code health. I think code health really helps. In my opinion, every software has product has a 15-year cycle. It's 0 to 2 years to build it, depending on how complex it is. About 7-year shelf life, and then 3 years it's in maintenance mode, and then there are the last 3 years where it's in deprecation and migration mode. Having the focus on code health right from the start really makes this journey on the later part a lot more easier. We know by experience on Google where we've had to deal with this on projects which didn't have code health and had code health, and it's a day and night difference. So again, that's why moving fast is good. But breaking things isn't, obviously. The most important part is, we owe it to our users to ship high quality products. And all companies and businesses do. Unbaked features really lead to a crappy user experience. Or if you ignore quality, products just build up bloat, feel clunky over time. And at the end, that doesn't result in successful products in the long term. It also really helps. A lot of big tech companies are getting into this phase where they are having a hard time shipping, keeping, like their launches slip into years. And I think if you have the focus, really, the one way to not get in that state is really ensuring that you have the focus on code health and you move fast, but you don't ignore quality. So Alistair is here somewhere.
SQL.js.
Yes.
How do we install this
so
thing?
I'm borrowing this slide, this image from him, because over the years I think I found this a great way to communicate to people what I think about my testing philosophy or automation philosophy. I believe a lot of teams and or companies, when they talk about automation, there's a lot more emphasis on UI-based automation. And that is unfortunate because, in my opinion, UI automation is actually the hardest thing to do with all the moving pieces. Very often people just don't stop at the UI automation. They want to test the whole stack. My litmus test is I know a team is doing too much UI automation when they're catching the null pointer exceptions via the UI test, essentially, right? So, so I believe, I mean, this cone needs to be inverted in more teams than not. Manual session-based testing is, in my opinion, a fancy way of saying exploratory testing. But I believe exploratory testing is great because and I wish my teams can do more of it, because your automation is hitting the same code paths over and over again. And exploratory testing is the way you're going to be hitting these other code paths which don't get excised otherwise. So and I strongly believe that if the testers are rerunning the same set of test cases over and over again, those need to be automated, unless in rare circumstances the return on investment is not there. API tests are, I think, great bang for the buck. I mean, these are relatively simpler tests to write if the APIs are defined cleanly. They are almost always stable and almost always have a binary signal. Everyone likes integration tests. I mean, everyone's like, oh, more integration tests, more. But I've seen beyond a point, integration tests stop being an asset and become a liability because the signal to noise ratio flips. You just have too much noise. So you want to have integration tests, but you want to have a healthy dose of it and not too much.
How much is too much?
The component tests are essentially, if you have a stack, you start isolating, and I talk a bit about it later. You test each components in isolation and fake out the other things, which helps you really not run the whole world in terms of tests. And yes, the unit tests, of course, are essential. I mean, Google's always had a high bar on developer testing, and I think we continue to do that. So the rest of the slide is going to be talking about this flowchart, so I tried to take a step back and summarize what are the things we did really to take our journey of moving fast and not breaking things. I could think of 10 things. Let's talk about them. So the first one is what I call push on amber. But before we talk about that, I want to take a detour and talk about push on green. This should be a concept most of you would have heard. Kent, I think in 2003, came up with this concept. And I think it's a great one. If your company and your team is not doing this, by all means, please start with push on green. At Google, what we started realizing about half a decade back is push on green was, in some cases, starting to stop, not enable, but limit us in what we wanted to do. There are some teams which had tests, so
here's the execution method.
Which were changing under the hood, and the test would fail. But it wasn't really, the test was failing, but the product wasn't, and should you really be slowing down the product for that? Or we would actually find a bug, but the bug was in the back end. In the stack, it was like 2 levels down the stack. Should you be blocking the entire stack from going to production for a bug at the 3rd layer of the stack? So we thought it was time to take more risks and do what I call push on amber. The expectation we set and we mostly meet is we say if you check in a change list at around 4 p.m. today, it will be live in production at 4 p.m. tomorrow. This really helps us ensure. And I want to actually take some time and explain a bit more how we get there, because most people are either shocked or fascinated by this. We'll see which camp you guys are in. We have hourly snapshots of our essentially of our stable top of head, we call this fish food. I talk a bit more about this later. At around 6 p.m. every day, we take the latest snapshot and we graduate it to the next day's prod bound release. We have a team of calibrated testers who we have worked hard on calibrating the product, who immediately jump on this candidate, if you can call it that, and over the next 4 to 6 hours, run a combination of regression tests and exploratory tests. And I think at an average, even with all the automation we have, at an average find 3 or 4 regressions. We have a simple rule: every regression is a regression and has to be fixed, because otherwise you start going into these debates of what should be fixed, what should not be fixed. We have another set of folks who, once they know these bugs are, they start culling through the list of changes and actually try to isolate what caused these problems. Again, that's a lot, and this was an aha moment for us when we did it. This is a lot easier to do with daily snapshots, or arguably hourly snapshots, because we have the data, than to do with a weekly one, where at times we would have excess of 10,000 change lists in a weekly snapshot. We know what those changes are. We essentially revert buggy code, or what we call internally rollback. We down integrate those fixes. We then do what we call smarter, I like to call smarter regression testing, where we don't rerun the entire thing all over again. We just regression test the affected parts of the code base. We, of course, do not bypass critical tests, around ACL, data, stuff like that. Of course, all of our automation reruns all the time, because automation is cheap. You just need to throw machines at it. So all the automated tests run at every step. We have also done some experiments along the lines of, we have actually instrumented our servers to help us assess the coverage of our manual and exploratory testing. Because while it's great to have numbers of your automation and your coverage, that really gave us an insight of, wait, we are testing way too much in this area. We're not at all testing very much. And we compare it with actually the code, where the code base is changing, and actually use that as a way to further refine how we spend our time doing exploratory testing. So that's what I mean by push on Amber. I like to, my mantra mostly has been, I've been telling the teams I work with, don't catch bugs, but prevent bugs. Because I think that's the only way to stay ahead of the curve. Too slow. So this is important, because I think the only way, trying to figure out how to phrase this better. I mean, we essentially want to ensure that, you are preventing, you are actually, the ideal situation is the checked in change list produce a perfect code. And while you can't get there, you want to get to a point essentially where you prevent, like you catch as many of your bugs as like you don't.
Amazing! We're reading the SQLite file now.
This is the point where I go to my notes. As I told you, I'm getting old.
So let's actually clean this up.
Yeah, so for example, so how did we do this? I think one of the ways we did this is we invested in what we call hermetic automation, and I talk a bit more about that. But we essentially said we are going to test our system under test and fake out the other servers it talks to in the stack. So that way, essentially the way to think about it is, if a change list is going to cause a null pointer exception, my example from the old days, it will actually, and if you have a hermetic test which brings up the server, it will not let the change list to get checked in the first place. because your server is not going to come up. So it doesn't even get in, and so you're not like dealing with like suddenly your staging server not coming up or stuff like that. Over the last couple of years here, we have taken it to the next level, where we've actually started recording our responses for some of these fake servers, which also helps us get our tests even more faster. And I'll talk a bit more about why fast tests are good. Just going to go by this. Okay. So what is a hermetic test? If you Google it, it says complete and airtight. I think this is a concept on which I think I've made my living at Google. Again, when I moved on some of the projects I was frustrated at seeing tests randomly switch from green to red and back to green. Again, I don't know how many of you have experienced that, but tests it's like watching Christmas lights on a dashboard. And it didn't help one ounce with respect to motivation, like telling people why you should write automation. Not to mention when you talk to software engineers, that why automation is good and why they should in turn also write UI tests and integration tests. So for a good year or so on the initial project, again on Gmail, I didn't really have a great solution, and essentially we just didn't write any more automation because we need to find a better way to deal with our automation. So there was temporary pain. My definition of a hermetic test has been, if I'm on a flight, I should be able to run my test and it should pass. Except now, like the last few years, they have Wi-Fi, so you can write non-hermetic tests in airplane. But that used to be my litmus test for years, and I would actually do that. In the initial days when someone told me, wait, we have a hermetic test of our project, the next time I would be on a business trip, I would try running that on a plane. And it would mostly work. So that was awesome as a litmus test. Because I think when you're not talking no network connection, it really isolates a lot of the flakiness you see in a lot of these end-to-end tests. A bit more about hermetic tests. So this is essentially like a complex web app has a lot of servers under the hood, right? There's the front-end server and a bunch of other web servers. So end-to-end test at Google is typically something which makes a request to the server, gets the responses from these other backends, and gives you the end result, right? But the problem with this is a lot of these backends introduce variance, flakiness, there's network. This is what leads to a lot of the fun, interesting flakiness and debugging sessions a lot of us have. Okay. So when it comes to, what we did essentially is we designed hermetic servers. And again, we said it's a server in a box. We're essentially going to try and have our entire test come up on a box. It can be on different boxes too, but if it's in a sealed network. We start the system under test. The client, it talks to the test client. It makes the request via the test client. We essentially fake out, we just use the in-memory data store. That way you reduce all the complexities out, and this leads to a test which is a lot more stable, and it also, the logging module we have actually helps us pinpoint where the issue is. And like we have a similar hermetic test for the other backend and so on and so forth, if that makes sense. Yep, that's the hermetic. So another thing is pushing. Like, we realize we can't do it all, and I'm sure this is true for a lot of you too. There's a lot going on, and you don't try to do it yourself. Like I like to say, spread the love of testing, right? When I started talking to a lot of these software engineers and asked them why they don't write automation, they essentially said the framework's just too complicated. Or wait, I'm writing my code in JavaScript, and why are you making me write my test in Java? I want to write the test in the same language as the application. So we invested what felt like almost a couple of years, maybe it was a bit less, in building baking in automation frameworks within our tools. the automation compiles. It's a feature essentially of the product. It compiles with the product, which means your automation, no one can break your automation framework, right? Because it compiles with the product. We of course ensure mostly that doesn't ship to the end user. We've ended up doing that a few times, but we've learned and not to do that.
Why is it complaining?
So that's really helped us
Is it comma?
getting the software engineers to
I'll comment this
get
out.
involved in writing the tests and owning the automation they write. So this particular flowchart, again, I think most good things in life are accidents, and so this was an accident. This might be one of the most important things I've done at Google from a prioritization perspective. We just had too much going on Google Plus, right? It's like we launched 100 features in the first 100 days, and there was no way we could test everything, and the onslaught just kept coming. And so I was just trying to figure out how do we scale our testing efforts? Like what do we do? And I literally, this was just thinking stuff aloud on a slide. But then few folks stumble upon it and they're like, oh, this is great. Yeah, we'll just do this, and this helps us figure out what we should test and what we should just make the PMs. So what a lot of what this led to is it helped us define where in
I don't need the function keyword.
Test. This also helps us, helped us as a byproduct throttle the number of integration tests. Again, in an ideal world, it would be great if every feature had an integration test, but I think they come with a cost. So actually, this helped us focus on having integration tests for the right features. It also helped us really get everyone involved in testing. Like like a lot of product managers and software engineers were actually excited and collaborating on test plans, doing bug bashes, and like we really made it an effort to make them self-service. And to date, this is how we continue to scale. Which allows us to really focus on fewer things but do it better. Okay, I'm going to speed up a bit. This is important, delineating product releases and features, because this helps disengage the release train from feature changes specs, because they keep changing. This also helps that your features don't have a hard dependency on each other. If one feature is not ready to launch, you just don't flip on the experiment and it doesn't launch. Like when we launch, essentially what is a product release? When we launch, like we launched last week, we launched Inbox by Gmail. Some of you might have invites. Others want invites. Grab the Googlers here, torment them for invites. It's cool. And like a feature would be like Google Plus recently launched like the polls feature in Google Plus. So that's kind of what I think the difference between these two things are. It also helps us really launch a lot of things silently, because Google does things at unprecedented scale, and this lets us actually figure out how a new backend or a new feature and the RPC.
Yeah, we can just inline this stuff.
Fit into the current stack, which in some cases is barely hanging there by the thread. So this helps us do a lot of like, if I were to say invisible testing under the hood. And more importantly, if we find we launch a feature and it has a critical flaw, we just turn it off, because it's an experiment or a flag. We can just turn it off and not have to do an expensive binary like a release rollback or roll forward. So this has been something which has really helped us, enabled us to take more risks too.
Delineate products releases.
So productivity, why is this important? Yes, users come first, but you need to take care of yourself and your product team. If the team is not happy, they won't do good work. They will, and eventually result to not so great products and unhappy users. So I have this dream. Sound like Martin Luther King, but it's invisible tests, right? I mean, if stuff works, you just don't notice it. It's basically it works. It's like it's your car. Yeah, it works. You're not like you don't know under the hood how many things get switched or whatever. It should just and we are getting there in a lot of places. We are actually at a point where we have now under 5 minute UI automated tests on some of our projects. That includes the whole shebang: build, test, setup, teardown. and we are trying to figure out how to like scale this at a Google level. And a lot of tests. I remember someone senior at Google once telling me, he's like tests have become like you need to ensure that tests stay an asset and don't become a liability on your liability. So I think that's really important. I think flakiness, I have a personal belief that flaky tests are worse than no tests. And I know we have a few talks around flakiness, so I'm interested in seeing what other people have to say. But when I joined a particular team, they told me they have thousands of automated tests, and I was excited. I'm like, what? And then I'm like, wait, where are they running? Oh, they're like, oh no, we have them. Only like 70 of them are running. I'm like, wait, what's wrong with the others? They're like, yeah, they're like this Christmas tree thing, right? So I'm like, yeah. So I think that is what really is a big productivity killer. So. Yeah, I just don't attack, kill. I don't know. I want to kill is a hard word, but yeah, bad tests are terrible. You should like plague. You need to. In my opinion, there are two kinds of bad tests. Maybe there are more, but slow and flaky. I mean, when you want to move fast, ship to production daily, you need to have fast tests because you want to run your automation at various steps of these thing. And if you have slow tests, then that doesn't help. Even one flaky test, if you have 10,000 tests, even one flaky test out of that is going to cause a submission to fail. So it doesn't matter if that is just 1 or that is 10. I mean, so that's kind of why flaky tests are horrible. So we really have a laser focus on this. Like a recent example on one of my teams, we knew over a few quarters we knew we had a bunch of flakiness that creeped in a particular area, and we actually had a bunch of fixes lined up. So again, going back on the philosophy of tying everything behind an experiment, we made a bunch of changes and actually put it behind an experiment. Because the other thing is, I think some of this work at times doesn't get as appreciated as it should, and one way to do that is if you actually quantify its impact. So we actually, rather than like just making incremental changes, we did in our own little ecosystem, but then we turned it on via flag switch, and so like the graph clearly shows that the flakiness really went from like the downtowns to the suburbs, I guess, whatever you call it. Another thing which one of my teams has done, and we wanted to name it Robocop, but there are already like 50 Robocops within Google. Like it's a pretty common internal project name, so we call it.
How is that possible if it has values?
But it's the goal with this is to take the source, to inflict the pain on the person who made a test slow or flaky, and not the team. Like if you like, so we have this thing automatically just like in the background keeps running and collecting data. I believe we have the threshold set at about 3 flakes in 100 runs or something. But it automatically pulls a flaky or slow test out of the critical pre-submit or continuous build, and it logs a bug, so you're not just ignoring the problem. We are super close to having. Where's Jen? But yeah, we are super close to having culprit finding in there. So again, we'll be able to actually find out what the change list is which introduced this problem. And then when things actually get stable or fast, they automatically get put back in. And we sync it with everything. And of course, we have a blacklist of like critical tests which whitelisted. Like you don't take out the ACL test no matter what. If it is flaky, you fix it. You don't like ship without the ACL test. So that's something exciting I think we're doing. This will circulate over at some point. You don't know where you are going till you know where you've been. I don't know if that makes sense, right? So I mean, it's a fancy way to say metrics. I like metrics which can be automatically generated. I hate metrics which you have to put on a spreadsheet and calculate every week manually, because you just don't do that after like a few weeks. I think fortunately Google has good tooling and it's improving exponentially right now in terms of metrics. So I'm not going to read out each and everything on this slide, but kind of tells you guys like the areas I think we believe are important areas for us to keep an eye on. Uh, uh, Again, the goal is to move fast and like don't break things. I want to, the two things which are red, and I want to explain why they are red. Like, wait, why is it bad to have more automation? So by the way, that's 114,000 days. Yeah, so, and think that equates to, I don't know, but yeah, it is basically, that's the, if you calculate the amount of time our automation ran, that's what it equates to in this year so far. And I actually got this data probably 3 weeks back. That's great. In a way, you have more automation. That's bad because we believe that as we keep adding more automation, we want to make it more and more efficient. Our tests need to get more and more faster. We want to 5-minute tests are great, but really it's code. It should just like compile and like your test should be 10 seconds if needed. So as we add more tests, we actually want to add more automation, but we want to reduce the amount of time our automation runs. We want to get smarter at how we run it, what we run, how long it takes. And similarly with the pre-submit time, and again, the reason that number has really fallen off the cliff is, again, a lot of the work we have done. We've had a big focus on speeding up our pre-submits. We took a lot of our flaky tests, slow tests. They get pulled out of pre-submit. So that's great, but that's nowhere as close to where we would want it. We would want, again, the dream about invisible tests. We want it to be there. Yeah, that's kind of, I think, the key things I wanted to highlight in this. Okay.
I think I should pass now.
Fish food.
There.
Dog
No
food
idea
is a
why.
common industry term. We wanted to take it to the next level. Fish food doesn't taste great. It's yucky, hardly edible, but helps your immune system. And that's kind of what we mean by it in terms of using it for our product. You expose the pain, right? You share the pain, expose the pain. Like if you have bugs where you can't send an email or you can't make a post, there's a good probability whoever introduced that bug will also see it and they'll fix it. So this also helps with rapid iterations, right? You can iterate rapidly, and these are the early snapshots I spoke about. I don't actually sign up my teams to manually test this crap. I hope I can say crap in a public conference, yeah. Because there's a lot of moving pieces here. Again, the concept of hermetism and applied to manual testing. Yeah, I think the features barely, the moment a feature is implemented, like someone might have implemented the button but not implemented the action handler on the button, which means you see the button, but that will just do nothing. And if you expose testers to it, they log a bug, they know I clicked the button, nothing happened, but that's because, yeah, it's getting implemented. It'll be there in the next hour maybe. So we actually try, we have no SLA from a test perspective, but this really helps us, have rapid iterations, rapid turnaround time. We've had like, more than often we have like 4 hours from like the time like a feature is thought about and you actually see it somewhat working. So I think it's pretty cool. Prioritize releases, right? And the way
should pass now.
Like the grass is greener where you put
not.
more water, essentially, right? If you don't prioritize releases, at the end releases is the way you get everything out. So you really, you need to make postmortems. I mean, the thing at Google, postmortems need to be part of the culture. It's actually, postmortems are a great way to learn from mistakes and actually improve tooling, infrastructure, process. At Google, we actually have a
context is not set up here.
Bad Postmortem of the Month award. Actually, didn't know that till 2 weeks back, till my team actually had to, we did something really bad. They said, but wait, you will probably qualify for that award. I'm like, sweet. Yeah, Google's great. All sorts of perks, I tell you. And it's also good, having an on-duty rotation helps because everyone knows how the stack works. Every software engineer works in isolation and each are their part of the puzzle. And going through understanding how the releases work, give them a perspective of how the product works, which in turn, we have got most feedback from them really helps them build better features down the line. They think about implications up and down the stack when they go back to do this. So I think this really helps. So again, I spoke about so treat regressions as build blockers, and the best way I can the analogy for those of you who have done this is knitting. I did this years back when I was in school.
I would just do it like this.
If you make a mistake in knitting, what do? You undo what you've done and then you redo it. when I used to try to do anything, I think I undid more things than did, which isn't possible, but I felt like it. It's kind of, this is a cultural shift, and I think it's important because like I stopped doing rollbacks. And one way to enforce this is I just started rolling code back. And I stopped doing it after I crossed about 1,000 changes. Because by then people got the idea that you should do this. And now we are tooling our continuous build system actually auto rollbacks code that doesn't compile, or code that breaks more than 1,000 test targets. And we are actually evolving that into like more finer thresholds. But the key is, this is a guaranteed fix. Whereas if you try to make a speculative fix,
no, it broke.
It might fix one thing but cause another thing. We actually, at times, we favor, like the changes you want to roll back is maybe 4 changes deep in a list of changes. We actually roll back all 4 of them, and then we resubmit the top 3. So that still means that we have removed the buggy code, and then we have essentially like back to where we were. And this gives people more time to react. You're not like, someone's not on like at their, especially if you ship daily, so no one has a gun on their head and say, oh, you need to fix this, and you better fix this before you go home and stuff like that. Murphy's Law. Anything that can go wrong will go wrong, and it does more than often, right? So this is the slide where I'm telling, as optimist a guy as I am, I'm like, we need to be a pessimist. Hope for the best, but prepare for the worst. Like this is where you put on your tester, or there's your like how to break things hat, right? Imagine all the possible things that can go wrong. Some of the things which we have done here are things like, we call it missing backends. Like we actually take a perfectly functional stack and randomly start killing servers. I mean, not on production, mostly. And see how the system behaves. Does it degrade gracefully? Like does the functionality which not depend on that part of the server actually work? So we actually have this, and in some cases we actually have it automated, so this continuously runs and helps us identify problems. I wanted to earlier this year, Google had an outage where, and this is on the Google blog, but a bunch of services, Google Plus, Gmail, you couldn't, for about 25 minutes, users couldn't log on, right? Because the configuration at Google was pushed, which tells other services at Google what to do with user requests. And the software bug caused the bad configuration to get pushed. And that caused the user request to kind of black hole and stuff. So we've taken that very seriously, and since then we have actually put in significant efforts around making sure all automated configuration folks, like machine generated code, and we test it to the extent we can, because it turns out you can't even trust that. Lastly, so this is like sangria. You can keep making the best sangria ever, but at some point you just want to.
Is that a drink, or is that? Let's check that out.
Sangria. I don't believe in being a gatekeeper.
That would be nice now. Thirsty.
I believe the test engineering organization is in a great position to provide a good risk assessment. We tend to get involved, our power users involved in helping us giving feedback, especially as we get closer to launch. We in fact have if you want to get on the Google Trusted Tester program, we'll try and circulate a form if you guys want to know something. That also helps us get very valuable feedback on the product, on what things we should do and shouldn't do. This is really where you have to balance how much you want to go velocity. We of course don't compromise on anything, ACL, security, data, stuff like that. The things which you can't compromise on. So if you were sleeping so far, wake up, and this is essentially
time to wake up, guys. Wake up.
All this while, right? So for those of you who don't hate boring talks and don't like slide decks, this is it, really. I wanted to just end of course the world is moving to mobile, and while I knew this graph would be upward, I was surprised how upward this graph is. So, I mean, we clearly, this poses some interesting challenges and opportunities for us for our move fast and don't break things model. Uh, I think we need to make some adjustments. We need to rethink some of our tooling. Uh, I, for starters, you can't push daily to users. You can, but it'll be kind of lame. There's battery, data, there's network limitations. So I think also like the state of tooling has to catch up and evolve in the state of like web and server tooling. And I think at Google we have a big push for it. But I think we need to, like, it's a challenge to have blazing fast tests, especially when you're using emulators. We have come a long way in speeding up our emulators, but a lot more needs to be done. Like, it's interesting to test automate battery testing, right? I mean, how do you, like, the moment you connect your phone to a machine, it's charging. How do you test the battery when it's charging? So we do it in a weird way, but so those are the kind of challenges. How do you do this in a way that scales? Integration testing has to be rethought, right? So this is actually an area I'm hoping over the 2 days you guys are here talking. I would love to hear thoughts, ideas, or we want your opinion. We want your thoughts on how you think things should be done in the mobile first world. We have a few things in flight, but again, I didn't want to make this a 3-hour talk. Also, I think we want to polish what we have a bit more before we share it with you all. I created this community. We'll see how far this goes. But again, I hope this discussion doesn't end here today. So I would love to hear thoughts and comments from most of you guys on how you do things. And that is it. This is my last slide. Yay. But another way to look at this is, in my opinion, it's not all about tooling or technology. A lot of this is there's a cultural element, and I'm involved here. And in my opinion, if you have to bucket these things into these 3 areas, there are things which fall into the cultural part, which doesn't require a single line of code or a single tool to be written. There's tooling. Some areas require tooling, and some areas a combination of both. So that's it. Thank you for not throwing any rotten tomatoes, but open to questions.
Thank you, Ankit. So do we have any questions?
Any question, guys? We might relay them to the
go?
past. Hopefully this works.
Hi there. Good talk. Thank you. Can you clarify, when you do your release cycles, you said you start at 4 p.m. each day, and typically the team finds 3 to 4 defects. You back those out before you push to deployment, or do you fix those in place the next day?
So if I understand your question right, we don't start. There's a cut happening every
Why
hour.
didn't it pass?
We just happened to
Did it
take
pass?
the one around 6
Yeah,
p.m.,
it
the
passed.
latest one, and graduate that. We find 3-4 defects. We fix them on the branch.
Fails.
And
Nice.
then we revalidate, but we do it in a way like we don't revalidate everything.
Smart evaluate.
And then I missed a step when I was talking. We push it to staging too, especially for servers which have state, because we can't. There are some corner cases which you only hit with when you expose things to millions of RPCs, and we let it sit on staging for a bit.
Millions
and then
of
we push it to
PCs.
prod.
Amazing.
But at staging, there's a bunch of other metrics we go into, but that's a topic for another talk altogether. But yeah, I hope that answers the question.
Good. Thank you.
Hermetic tests.
I do have a question about your hermetic tests, and I wonder, given if you isolate the dependencies by faking them out, that in itself creates risks. How do you manage the risk of making sure that everything will still run when things are not stubbed down?
So that's a good question. What we try and do is simplistic. Let's say a stack has 3 servers, and you're taking one and faking 2 out. What we essentially do is, in the old world, we would have 1 test where all 3 would be running. In the new world, we would have 3 tests, which essentially have one real and 2 of the other fake. So you are writing 3 tests, but we parallelize all these tests. So in essence, you're doing the same testing which you were doing with the one test, but you're parallelizing
The comments are brutal, man.
One of my teams has also come up with this interesting concept called cutover.
It could have
we
prepared
actually
more,
are-
that is true.
We have a prototype ready where we are actually working on a fake.
It wasn't
which
that
doesn't go
bad.
stale. It's actually a pretty cool idea. The fake actually inherits a lot from the real server works, and it kind of keeps itself auto-updated. But that's kind of all said and done. There have been some instances where we have these 3 tests, and some stuff is still broken, but then that one test was still happy, like, still didn't catch it because it's just something. Depending on how deep of a stack you want to go to. I mean, Google stack is pretty
Yes,
10 level.
that's a popular topic, and we're gonna move right along. Oh, Merlin Van.
Do you have any examples of enterprise level applications where what your application is doing is transactions kind of things? And then if you release in production, there could be a customer out there who is so unique in the kind of configuration that the customer has that you may not have covered in the possible scenarios in your testing, and then there is no way to roll back. You have to roll forward for the transactions.
No, and that's a good question. So overall, how does this map to the enterprise world where, well, there is a different risk tolerance level? The example, again, when on Gmail, we have paying customers, right? The enterprise version of Gmail. And for some of our big customers, we essentially created, we run all these tests in all the enterprise. Like we don't, not for a specific company, but we run it in education mode, premier mode. So we actually have all this replicated across the different modes. And that's how we kind of, but yeah, there are these special use cases. But in general, I think Google's done pretty well, not trying to get too rattled into very customized enterprise hookups. In terms of transaction stuff, they still have hermetic tests, but I think there we actually, at times some teams cut daily, they actually canary for longer, and they push, like they still have daily cuts, but instead of pushing daily, they push, say, every like 3 days. So it's a risk and tolerance. Okay, I'm getting the placard. Thank you guys. I would love to hear more from you guys over drinks later today, but thanks again.
Nice. Let me know in the comments or in the chat what you guys thought. And yeah, so I actually wanted to fix one more thing before wrapping up today. I was looking at the, let's stop that. I was looking at the SQLite database earlier, and I think I figured out where the deck information is. I haven't figured out the relationship between the decks and the nodes. That's something we still have to figure out because I just don't know, to be honest. There must be something here that indicates. But I think we can read the collections, and then that way we know what the deck is. And it looks like this JSON structure, every deck is essentially a collection. We're not gonna take any of the template stuff, so we can ignore that. But I would like to figure out the relationship between the nodes. That's the second thing, right? First thing is just reading this. I think we can make a database query to... it would just be the same, right? It would be select from call, collection this time. Where is the... is it this one? Yeah. So that's how we get it. And then we would need to read the JSON. I'm not sure if it's actually JSON by default. So yeah, I remember, Marcel, you sent the link before the productive developer. Did you watch that talk? Was it any good? We could watch bits of it. Yeah, let's actually, yeah. Let's do that, and then I want to get some more delicious hot water. Const all what are we gonna call this? All decks. Well, where did he send me that? I have to find it. I'm not sure where he sent that. Was it in a DM maybe? It was probably in a DM. Huh. Yeah, I think it was productive habits developer maybe. There, habits of efficient developers. Found it. Oh, and it's actually not that long. We might be able to watch the whole thing actually. So, let's see. We'll take a short break. I don't have a be right back screen anymore. I actually deleted it. So let me try putting this up here in OBS and then actually adding some text. Let's see. Yep, and let me try to write. Be right. Oh, did I put it in the long place? Yeah, I did. Let me move it to. Can I drag? No, I can't. I can't even copy it. Yeah, I'll have to move it. Da 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 da. Yeah, I'm trying to align this thing here. Where do I pick the font size? Whoa, that's huge. 256. That's massive. We don't want it to be that huge. There. Be right back. Should I maybe change the... I'm spending a lot of time on the font here. There. Should be visible. back. So, let's get to this talk. Yeah, so the talk, just to make sure we mention it, so it's from We Are Developers. I think it should be fine to play it. They have the copyright, and yeah, I'll drop the link later.
Hello, everybody. My name is Daniel. I work for a company called Acro, and we are here today to talk about efficient.
Let me mute.
So the first thing that I want to do is define what we mean by efficient. To be efficient means achieving maximum productivity without wasting resources. And in our case, as developers, that resource is usually time, which means to be efficient is to do things fast. But this definition is missing one key element for us that we can see in this quote by Peter Drucker. To be efficient is to do the things right, while to be effective is to do the right things. So to be efficient is not that we have to be very, very fast. It's the things that we do, we have to do them in a proper way so the decisions that we take today don't slow us down in the future. Now that we have this quote here, you may be wondering, well, what is more important? To be efficient or to be effective? Obviously, it doesn't make any sense to go really, really fast if you end up in the wrong place. But equally, if we know where we want to go, but we never achieve that place, it doesn't make sense either. In fact, there is some synergy between the two. If you are efficient, it means that you spend less time, takes you less time to do things, which means that you have more time in your hands to stop, look around, and make sure that you are going in the right direction. So to be efficient allows you to be more effective. Now, in this talk, we are just going to focus on what it takes, what it makes us efficient. And we're going to start talking about focus. There are plenty of studies that try to quantify what is the cost of an interruption for us developers. And it seems that the cost is around 10 or 15 minutes. So every time that somebody comes and interrupts you, it takes us between 10 and 15 minutes to reload the context of the task that we were doing to be able to be productive. So it's paramount to be efficient, to minimize the number of interruptions that we get. So we have long periods of time where we can focus on the task at hand. There are basically two types of interruptions, the ones that you control and the ones that other people control. Of the ones that you control, these ones, email notifications, are probably the worst offenders. If you think that that little pop-up does nothing for your concentration, the truth is that for your brain, it looks more something like this. You cannot just stop looking at it. Millions of years of evolution have made our brain really sensible to any unexpected movement, mostly because the fear of being eaten. So when that little pop-up shows up on your screen, you have to focus on it. You don't have an option. So efficient developers, the first thing that they do, they disable all notifications. Not just email notifications, but absolutely all notifications. In fact, you don't even want to see that little number with the number of unread notifications on your screen. Because as soon as that little number changes, your brain is going to pick up the change. And you're going to start thinking about, well, who sent me an email, or what do I need to read? So you should always, you can always deal with emails whenever you want, whenever you have the time. Nobody should expect that you reply immediately to their emails. There are other means of communication that are more appropriate if something is really, really urgent. Emails are asynchronous, and it's more efficient to deal with them in batches. The only notification that you want to see is the one that tells you that you broke the build. Yeah. And please never be one of these guys that they type an email and they run to tell you just to make sure that you received that email. This is really, really annoying. And this brings us to the other types of interruptions, the ones that you don't control. What can you do when somebody comes to your desk and interrupts your flow? I know 3 possible options. The first one is to wear some headphones, really, really big. So when somebody comes, you pretend that you didn't see him. And you hope that he will just walk away. The second option is that you have a very good team lead. Somebody like this guy. Somebody that is able to tackle any interruption before it reaches the team. The third option is to do pair programming. If you are doing pair programming, when somebody comes to interrupt you, what should happen is that one of the 2 developers in the pair should stand up, walk away a couple of meters, and deal with the interruption. And when he's done, he goes back to the other pair. And that other guy that was able to keep focus, it works like a really fast cache to get him into a productive state a lot faster. The additional benefit of pair programming is that because you have another developer looking at what you're doing all the time, you are not going to check the news or your phone or your email as often. So that peer pressure is just going to cause you to be more efficient. I don't think I need to explain this, right? We all know this. And I don't like to sound like your mom when she tells you to eat your greens. So let's move to the next one. Efficient developers just do one thing at a time. And the reason is exactly the same why we hate interruptions. Yeah? Because of the context switches. Here we see that doing the blue task after finishing the green task, it just takes less time. In fact, it's not just that it takes less time. When you try to do multiple things at the same time, the quality of your work usually suffers. We all know that the definition of multitasking is just screwing several things at the same time. So you should always focus on one thing, if you finish, and then you move to the next task. You, me, we are all going to spend thousands upon thousands of hours in front of your IDE. It's one of our main tools. So you really need to know it inside out. Because any efficiency that you gain using your IDE is going to be multiplied by those thousands of hours that you are going to spend in front of it. You just basically need to know 2 things, its functionality and its shortcuts. Now, just because you are sitting already in front of it for 6 hours a day, it doesn't mean that you are going to master it. To master your IDE, you have to make a conscious and deliberate effort to learn it, to find what functionality you don't know about it. You can read the release notes, you can follow blogs or YouTube channels of people using it, or you can just do pair programming. When you do pair programming, each of your partners is going to show you how they use the IDE, and it's going to show you functionality that you didn't know about, or it's going to show you more efficient ways of doing some task. Also, you can teach him your tips and tricks, so you make the whole team more efficient. I'm always surprised about the amount of manual work that we developers can put up with. And I found it very paradoxical, given that we are paid to automate other people's job. Manual work is not just slower to do, but it's dull, boring, and it's error-prone. So I always wonder, well, why we keep doing it? I think one of the main reasons is that we sometimes forgot that we are developers. And as developers, we have this very rare and powerful skill that allow us to create an army of minions that will do as we say. They will not complain it, they never get tired, and they do it really, really fast. And I think we don't use this skill often enough. Sometimes it's maybe because we just end up with this kind of minions, but that's a different talk. Just to make sure that these things, I'm going to repeat it again. You are developers. You don't do things that your computer can do for you. So efficient developers, before starting any task, they always think, well, can I write a program to do the task, or at least to help me to do the task? And I'm not just talking about automating some work that can take you hours. I'm also talking about automating tasks that can take you 5 seconds, but you do several times a day. And I'm also talking about writing programs for one-off tasks that you're never going to do again. First, because maybe it's more efficient, you can do it faster, But second, because I hope that writing programs is fun. At least it's fun for me. More fun, at least, than doing things manually. To write simple programs, there is nothing like old good bad shell. I have been a developer for 18 years, and during those 18 years, I have changed operating systems, I have changed programming languages, I have changed IDEs, I have changed my mind about all kinds of ideas and practices. The only thing that has been constant during those 18 years has been Bash. So I want to show a little demo about what Bash can do for you. Is that big enough? Big enough at the end? Cool. So let's say that your business manager tells you that some other team has created a program, and that program is collecting news, and he wants to know how many news per country we have. So you jump into the box, and the first thing that you're going to do is write a program. This is a program that is going to tell you how many news we have. This is a program, right? Around 4,000. So now, let's see what we have in one of those news. So it seems that it's a piece of JSON, right? That kind of hard to read, so we format it. So we see here some news with an ID, some social stats, the site that we come from, and we have here the country. Yeah. So what we are going to do is write a little program to extract that country. So country, quote, quote, single quote, one single quote. Okay, let's see if that works. Yeah. So we see, where's my mouse? Here the country. So now let's try to extract it. We start doing ref -o, we get something, and now we want to get the whole line. So you don't get too lost. Here it is, our result, country, and then we have the US. So what we are going to do is now split the line with a delimiter of quote, and we want the field, I think it's the third or the fourth. It's the fourth here. Cool. So now what we have, it's a program to extract the news, the country for a news. So we just want to do the same for all the news, and now we just need to sort it and count it. There it is, because we want to sort it again, so we see it in order. So we get that for this country, there are around 3,000 news. But now that we have this program, let's say that instead of the country, we're interested on the site. Yeah, we see their number of news per site. But now your business manager comes and says like, well, I want to know what are the top 3 websites for each country. So we're just going to modify this program a little bit. We grab country, let's try, for example, IL. And if I didn't get that wrong, those are all the countries, so we just want to sort them and take the top 3. That's it, and now we are going to format it. So it all
Hey, it's Jay.
so
What's up? Hey Alex, I just finished watching your video on incremental reading with Notion Tonki. Have you found anything for PDFs? Yes, I actually have, and I'm not happy with all of the things I've seen. So I think the best thing currently, if you're not like me and have a huge collection, is probably Polar. I don't really like it, to be honest. I feel it's too slow. But it could be my setup, right? So are you familiar with Polar PDF? This is what I've heard is the best. But to be honest, guys, I feel like it's too slow for me personally. So I would not use it. But you can, have you tried Polar? It's Jay. Let me have some delicious green tea. Yeah, please try Polar and see if it works for you. If it's too slow, don't use it. But I think, like, since I have an old Anki user account, like old relatively speaking, I've been using it for a while. I think maybe there's just some weird stuff with my collections. So I can't really use this, and the syncing is too slow for me.
I'm going to then move to the next thing, that is whenever
But,
you're writing a program,
I was talking with...
the amount of time that you are expected.
let me just mute this tab.
This is a good example, right?
I was talking with Slim Shady on the Discord. I do have some ideas based on the conversation I had with him on what we could do. It's just I haven't gotten around to doing it. But PDF support is like, it's a pain in the ass for me too. Like I have for my Japanese class, I have a bunch of PDF documents that I've gathered the last 2-3 years, right? So I wish I could just instantly turn them into flashcards very easily, or at least have a workflow so you can go through them. It's unfortunately we're not there today. I personally really hope we have something later this year, maybe around Christmas time or early February next year. So yeah, it's not that. Oh, there's the Nightbot with the YouTube. Yeah, so have you been using Anki for a long time? Do you have a lot of collections? No. Yeah, you could say I am annotating, but what I try to do instead is I try to batch process my PDF documents.
But once you are
So I do them all together at one time and then just get done with it.
and UIs just constrain what you can do.
We're gonna get this to work and then wrap up for today.
And if we're talking about avoiding UIs,
I don't
what you
get it,
want
like-
to avoid is your own application.
Let's pause this, put on some music. Let's put on the music on low. Something is weird here. Ah, I see. It's okay. Now I get it. It's a multi-dimensional array. Right? No, is it this one? No. So what are you studying? It's a J. Value. I have the JSON payload here, but I'm not sure what's messed up with it. Here's the payload. I'm a stats master student here in the States. Nice. New directives? No. I work as a part-time web developer, and I studied Japanese on the side. I was planning on retaking a math exam, but to be honest, guys, I never showed up to the math exam. I just didn't bother showing up. Let me lower the music, or actually I can do that in my headset. But I'm gonna be taking a driver's license test, and I hope to use Anki again for the signs. So, but that's PNG and SVG files. So I mostly use Anki for Japanese. That's where I'm using it. Can we get this passing? Let's try actually to have the music running and the video. How would that be? I don't think I could. No, we'll go back to the video then. It's getting a little bit distracting, weird, right?
UI. Right? There is nothing less efficient than starting your application, clicking things around, and filling up forms to know
Looks good.
if
Audio
your
waves.
feature is working or if you broke anything. Apart of making this thing more efficient, automated tests also give us the confidence to refactor and change code, because it's going to catch bugs, and bugs are the worst time waste of all.
Yeah,
First, you need to write
bugs are a huge time
bug,
waste.
then somebody has to review the bug, then you need to put the bug into
So the way I
production,
understand it is
and
the
then by
results is an
client
array,
user, notice the
and
bug.
then we
You
get
have gone through this
the
massive
columns, so we know the
context
index of
because
the
you probably
values,
wrote
the
bug
order
several
basically.
weeks ago.
And we're
If
interested
so,
in the DEX,
even
which
if
is
you wrote
further down,
the code that has the bug,
which is
that
probably...
code is already alien for you, and you have to dig into it, and then you need to fix it, you need to code review it, you need to explain it to your boss, you need to fill some Jira issues, and then you need to go again through all the release process. So bugs are just a big waste of time. But worse than a bug, it's having
Let's
the
start
same bug
here.
twice, right? So whenever you go and fix a bug, the
Find
first
the
thing that you should do
index,
is write
right?
a test to prove that you are able
The
to
collection.
reproduce the bug. You see it fail, and then you fix it.
Okay.
And the last thing that you want to avoid to do manually is setting up the development environment, right? This is not going to make you just more efficient, but the whole team more efficient. This is how
This is
structures,
how we do
for
it.
any project that I join look like from my point of view. And the only thing clear on them, about them, is they're not going to work. Maybe they are missing some step, or they're not precise enough, or maybe I will make some silly mistake. when
I
I
sang
try
that I
follow.
do when I
And the
heard it.
result is always the same.
Nice.
2, 3, 4 days of waste.
Do you like hip hop
What
or
you want to
R&B?
achieve
That's
is,
nice.
Instructions as close as possible.
We don't need to
just
write
one
this
code.
anymore. If we can get this
That one
pass
command
testing,
should build
this
all the
test
tools
passing,
and configure them
we
to be
can
able to build,
wrap up.
run,
Just this
and
one
test your
test.
application.
21,
If you need
21.
a database, it should install the database and
X
configure it and
column,
seed it with
press
some data.
column. What am I
If you
missing,
need an
guys?
build
Something
tool,
here is
Maven,
hidden in
NPM,
plain
whatever,
sight and I can't see
you
it.
should download the correct
Let's see. What
version
does
of
it say?
Maven
21,
and install
21,
it and
21.
configure any SDK that you
It
need.
says 10.
As you can see, my tool of choice right now
0,
is
1,
it's
2,
Docker
3,
Compose, which is
4,
Docker
5, 6,
You're not
7,
familiar with
8,
it.
9,
It's
10.
just
So it's off by
an
1.
example. And here we are saying that our development environment
minus
needs
1.
3 containers: PostgreSDB, RedSDB,
And let's
and
log
our
the
own
value
application.
now.
This has multiple benefits, right? First thing, it takes just minutes for somebody new to get started. But
It's
also,
still undefined. I
instead
don't
of
understand
working on
it.
your development environment, you can just
More R&B,
easily
lol,
deploy all
yikes,
tools and
MB,
start again.
more of a
If
Python
there is
ML dude.
change on the development environment, you know, it should
Python is
immediately
nice.
the whole tool, and the instructions never get out of date. Also, because Docker is running.
I like
in
Python. The
isolated
indentation stuff is
environments,
nice.
it means
But
that
I'm not a
every
huge
tool that
fan
you're
of
working on
YAML. This
uses
syntax,
completely different
the
version
YAML
of
files,
the
man.
base
Oh,
or a JD,
the tooling now is actually pretty good. But before, when
we are
the
going to
tooling
use
sucked and you had to indent everything yourself, oh,
And
what a
also, because it's
nightmare!
so easy
What
to
a
make
nightmare!
changes, it allows you, it encourages you to experiment.
Why is
If
it
you want to try
undefined?
a
This is
new
not supposed to be
JDK or SDK
undefined.
Or a new version of the database.
I don't get it.
Just make the changes, start it, and if you don't like it, you just completely wipe the whole environment. And the last section that we are going to talk about, feedback. Doesn't matter what you are working on, you should always try to find the shortest and tightest feedback loop possible. Feedback
How
what
is
it
this
tells us if we are
possible?
going in the right direction. Feedback makes us,
What am I
at the
missing
same
in the
time,
structure?
more efficient and more effective. You want feedback
It's an array
often and early to make sure that
with
you don't
two
wander on the wrong path
properties,
for too
columns
long,
and
with a
values.
consequent waste of time and energy. If we talk about the benefits of automated tests, yeah, we save time.
There's
it
something
give us,
weird here.
It catches
9.
bugs. It allows us to refactor. When is the best moment to write tests? Well, my opinion is before you start coding.
Ah,
If you're not familiar
this is
with
the...
TDD
Okay,
workflow,
now I get it.
basically this, going to go
Now
through,
I think I get
refactor
it.
You first write
Here.
one test and only one test.
It's a
you run it,
multi-dimensional
you see
array.
fail,
I thought
you
we
red,
checked that
and then you
earlier, but
run,
turns out we
enough
probably
code
didn't, so I
to
was
make the
wrong.
test pass.
So
And then you refactor. You clean up your code.
we'll try.
The
This
test
is the
just to make sure that
moment
you
of
do
truth. Does this stuff even work? Hopefully it works.
There are at least 4 reasons
Let's
why
see.
you want to use this workflow. The first one is the fast feedback that it gives you as you are building the new feature to know that your code is doing what you expect it to do. The second reason is that if you truly believe
It looks like
that
we are
automated
off
test
by
saves you time,
1.
you want
We're
that
getting the
benefit
model.
as soon as possible as you are
Looks like we're
developing the new
getting the
feature.
model. I see the N2A
The
close
third
notion to
reason
Anki,
is
so it's the...
organizational. I've
Now,
used too many times the phrase, I don't have time to write tests, or I'm not given the time to write tests. And for me, it just actually means that, well, I always write my code, I finish my feature, and once I have finished my feature is when I do write my test. And if there is any time pressure, well, you know, I'm not going to, I don't get time to write those tests. And because you don't write tests, it means that you don't refactor your code. because to refactor code, you need a very good automated test suite.
Oh yeah, we
Because
actually
if you
have to
refactor
loop
code,
over it.
it
So
means that your code starts to accumulate garbage. And because your code starts to accumulate garbage, it takes you more time to actually build new features. And because it takes you more time to build features, you get more time pressure. And you get more time pressure, so you have less time to write tests. Closing a vicious cycle that always ends up with the same, with us developers crying for a rewrite. And the fourth reason why you want
yeah, I think this
to
is
write your
correct.
test first, it's one of a mechanical reason. Because seeing a test fail is the test that the test tests what it's supposed to test. Or in simple words, how do you know that your test doesn't have any bug?
This is just Jason.
If you write a test and you see it red, there is a strong indication that is some piece of production code, some logic that is not there. If you write a test and you never see it red, well, you don't know if it is because you already implemented a feature or because you forget an assertion in your test, or the setup code is not correct. Now, when you present this idea to a lot of people, they always come up with this phrase. I cannot write a test first because I don't know what I'm going to build. And this can mean different things. It can mean that you don't understand what business is asking you to do, right? And in this case, it's true, you cannot write any test, but you cannot write any production code either. What you have to do is go back to business and ask for clarification. What do you want to do? The other case is that you actually understand business, and you actually understand the logic that you need to build, but you don't know if you're going to write one class or 10 classes, or if you are going to put an if statement or a switch or a factory. You don't know what you're going to write, but you understand the logic, and you understand the mechanics of the side effects. So you know which database you are going to use. You have used it 10,000 times already. You know the table. You know everything. In all these cases, you can actually rank a test first. But it's true that sometimes we actually don't know how to do the side effects that we are asked for. For example, maybe the logic for your new for a new functionality, it needs to call some RESTful endpoint to get some Forex exchange. And you have never used it, and you don't know the endpoint, and you don't know what you need to give to it, and you don't know what it's going to give you back. Or maybe you need to consume some messages from
I think I'm just gonna
and you have never done that.
tell
So you
TS
don't
to
know
back
which
off.
libraries to use, you don't know how they work.
Back off,
In all those
TS.
cases, you don't
It's
really
getting
know
late.
what you are going to do. There is always this phase of exploration that we have in our job that we use to fill up those gaps, to convert unknown side effects.
And the
into
JSON
known
is being
side
parsed correctly.
and that's something
What time is it out
that
here? In Norway
really
right now it's actually
doesn't
11
help
p.m.
with
So
what you want
tomorrow
to
I
do
have some
first,
track
with the
workouts.
translation.
I'm gonna
And
run
if
7
you
kilometers speed
And the second
workout,
thing, you
so I
want to
have
write
to
a lot of
go
little
to bed
programs
soon. But I want to get
to
this test
to play
passing.
around
What's
with
the
that
time in the
node.
US now? It's definitely
What is
different,
the
right?
best tool
Depending
that I
on
know?
where you are.
It's a REPL. REPL
I think we
is
found
a
it. This
read,
is
bulk,
the...
print loop, and it's just basically a fancy way of saying that you have like a command line interface inside your application. Instead of trying to explain it, let's see it in action, if it works this time. So I have already started an application with a REPL inside. and
Yeah,
what
in
I'm going to
Hawaii
do is
right now
from
for internship.
my
But it's
IDE,
11
I'm going
a.m.
to connect to that REPL.
If you drink coffee, you probably are on your coffee
So-
getting ready to lunch right now.
Let's say that you didn't know how the plus function works. So I write a piece of code in my
I think
IDE, and I'm
is
gonna show you,
Miami,
using a
no,
shortcut
not
to send
Miami,
that
I mean
piece of
Hawaii.
code to the application.
Is Hawaii on
And the
my list
application
on places I want to go?
tells
I was
me
making a list
first
recently.
thing, it's 5. Yeah. So I write
You
the
called
code
it
on the
literally
top
sipping.
screen, and
Yeah.
I get the results on the bottom screen. So as I was saying, this allows you to experiment with the library. So maybe what happens if I pass 3 parameters? Seems to work. What happens if I pass a very big number? I get an exception. What happens if I just pass 1 parameter?
Nice. So I think now we can actually access this
So this
thing.
is just understanding
It's
how
the data structure
library-
has
and
2
this could be
entries.
an HTTP library, messaging library, some concurrency library. We are just writing little programs and executing them to see what's the result. Let's do something slightly more fancy. Let's say that your business manager, it tells you that you have to build a new feature and you need some Forex exchange for that feature. And one of your mates told you that there is a RESTful endpoint to do that, and it gives you the the URL. So we wrote an HTTP, we make an HTTP request, and we see that we are getting some exception. Let's try to format that. Catch the exception.
Let's change this from D to call.
Catch exception.
And then for
Okay, let's try it again.
D and deck
So it tells us it's a
JSON.
400, which
Actually,
is our
let's-
fault, and we see here some body. So what we are going to do is let's get the body. Okay, that seems some piece of JSON.
So I'm probably going to make a lot of mistakes with regards to the data structures, but those can be corrected, and that's why we want to have these tests here. D.name, we can assume this is correct. And let's see.
Yeah, we get the exchange rates. What happens if I pass an older? What happens if I pass something in the future?
Where is it?
Oh, it still returns data. That's a little bit worrying. What happens if I pass a string? I get that error. So what we are doing is exploring how the real world works and how we are doing it. You write a little program, we run it, we see the result. So it's a very, very fast feedback cycle. Now you may be wondering, well, why don't you use something like Postman to do this, right? It's just HTTP RESTful, must be Postman. Well, there are some benefits of doing it like this way. The first thing is you have a full language. This is the production language, the one that I use in production, which means that I can...
Yeah, it's not
if
printing it out.
If I want to mix this data with something from the database, well, I know how to make database calls from the JVM. And also, if I now
I'm not a huge fan of this
and I
object.keys
grab
thing.
this exploratory code inside a function, and I don't get it wrong. This,
It defeats
what you see
the
here,
purpose
this
of
is
using
production
TypeScript.
code. As you see there, it's going to go to production. I'm making the changes in the project. This is
Now
not a
it's
different tool
executing
that
it.
then I need to get what I got from the tool and translate it to Java or .NET or whatever you are using. This is production code. It's ready to go. Also, because the REPL is running inside your running application, you can actually go and poke at the state. You can look at the state of your running application. And what we are doing here, if you notice, we are modifying a running application. And we are doing all of this without having to compile or restart anything. That's a very, very quick feedback loop. And I don't know if I mentioned it, but we are connecting to this REPL through a socket. And because we are connecting through a socket, it means...
All right, man, I'm gonna get some lunch, bro. I'll join the Discord and hopefully we can chat some. Yeah, sure. Thanks for coming by. It's a J. Have a great day in Hawaii.
Production code without stopping the application. This is extremely powerful.
We're getting close here.
And, you know, with great power comes great responsibility. So
Let's see. Deck JSON.
The last thing that we are going to talk about
Key.
is code reviews. Code reviews tell us if the design of the code that we are doing, if it fits the application. It allows or one of
Also
your
with this
teammates
test,
to tell
wish
you
you
if you
best
have
of
any
luck and good
bugs.
luck with your tracks.
And it
Yeah,
also,
thanks.
we
Thanks,
can use
man.
it to share knowledge, right? It's a way of sharing knowledge. So efficient developers want their code.
This should be it. I think it's gonna work
There is
now.
something very true behind code reviews.
Yeah,
When we are presenting,
it's working.
this huge
So what we're gonna do is, for the sake of saving time, we're just gonna create a new a new array somewhere here. Const
But when
dex
we get small changes,
equals
we're able
to
give
an
useful
array,
feedback to the author of
and
the
then
change, right? Because we are able to understand the change.
dex
Also, even if
push
you are very disciplined
deck,
developer and you go through that really
and
painful review process,
we can just
in my
remove
experience,
this.
what does it happen when you
We
go and tell
can
the author,
turn
like,
the
well, you know,
dex,
I think
delete
your
this,
design is
delete
shit.
these
No,
two
not your
lines.
We could improve your design. Or we could use
Okay,
a
is the
different
test
library that will
passing?
save us some time or some resources or whatever. What usually happens is that the author says like, yeah, I think you are right.
So
But you know, I have already spent
just
like
for the,
days or
yeah,
weeks working
I'm not sure if we want
the end of the sprint is tomorrow. So
if we want the
even if I think
default,
you
but
are
we'll
right,
add it now
I don't
here.
think I'm going to have time to do
There might be
change
some
what you are
issues with the
suggesting. It's
order,
going to
but
take me several
we're
months.
gonna reuse the same payload, so
Also, you know, it's already working. So let's do something different.
Actually, let's
just
change it
commit the
like
change as it
this.
is, and we are going to ask the product
the
owner
default
to
is
create
actually
a
the first
factoring
deck
state.
Anki creates by default. So Unless you have renamed it. There, the tests are passing.
I'm sure
Nice.
he will be delighted to
So
put it
let's
on top of
commit
the
that.
priority. And we all know that those things never happen. So you end up again with worse code that
Add
leads
support
to slower implemented feature with blah,
for
blah, 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 blah.
reading the
So efficient developers,
the
they
deck
don't
name,
want
I
just code
guess.
reviews. They want small and early code
This
reviews.
is just
So what they
the
actually want is
start.
continuous code
Getting
reviews. This
familiar
practice
with the
consists on
data
getting one of your teammates sit
structures.
just beside you.
We will
When you
probably
are implementing the
change
feature,
later
this
when we
developer sitting beside you is going
review
to
the
suggest improvements on your code. It's going to be
database
catching bugs
schema.
that you are
Lots of typos, guys.
and
Lots
for
of
the-
typos. I'm
for
getting
the,
tired.
Reviewer, the changes are really, really small. Yeah, as you type them, he sees those changes.
There.
And for you as the
Looks
author,
good.
you can get feedback even before you start writing any code.
Let's wrap it up.
Additionally, if for whatever
So
reason-
here's the talk we watched. If you want to watch it on your own, there's the link. And we might continue watching it. It's not that many minutes left, but I really have to get to bed and prepare for my track workouts tomorrow. So yeah, thanks for everybody who came by to hang out and write some code, watch some YouTube. And next stream is tomorrow at 7 p.m. You can check the details on Twitch somewhere. There should be a countdown, live counter. And we're going to be playing Minecraft, just the chill stream. And Marcel has set up a server for us so we can use that, thanks. And the link will be in Discord. I think I shared that earlier, but I can post it again for anybody who wants to join. There should be a command for the Discord. Hopefully it works, and it doesn't work. So just go to this website and you can find a link to the Discord. Have a great evening, morning, whatever, wherever you are. Until next time. Bye.